ഗുഡ് മോർണിംഗ്. ഇന്നത്തെ വീഡിയോയിൽ നമ്മൾ ഡിസ്കസ് ചെയ്യുന്നത് ഈ യൂണിറ്റ് ഫസ്റ്റിൽ ഏപ്രിൽ 2019 ചോദിച്ച ഒരു പ്രോബ്ലമാണ്. ഈ പ്രോബ്ലം എങ്ങനെയാണ് വർക്കൗട്ട് ചെയ്യുന്നത് നമുക്ക് നോക്കാം. എന്താണ് പ്രോബ്ലം? എ ടൈം മെമ്പർ ഓഫ് എ ട്രസ് കൺസിസ്റ്റിംഗ് ഓഫ് an ISA Indian Standard angle 65 by 65 by 6 mm. Length 65, breadth 65 and thickness 6 mm. Is welded to a gusset plate of 8 mm thickness. You see, this is the gusset plate. The angle given 65 by 65 by 6 mm. Welded. The question is to design the weld so that to transmit a load equal to the full strength of the member. That is the question. It's also given that the welding is to be done in the workshop. So shop welding. So that you can assume the value, the partial safety factor. Partial safety factor value ഒന്നുകിൽ 1.25 ആവും അല്ലെങ്കിൽ 1.5 ആവും. ഞങ്ങൾക്കറിയാം 1.25 എടുക്കുന്നത് നമ്മൾ ഷോപ്പ് വെൽഡിങ്ങിനും മറ്റത് ഫീൽഡ് വെൽഡിങ്ങിനുമാണ് 1.5 എടുക്കുന്നത്. ഇപ്പോൾ ഈ കേസിൽ തന്നിട്ടുള്ളത് ഷോപ്പ് വെൽഡിംഗ് ആണ്. സോ ഗാമ the partial safety factor is taken as 1.25. Okay. Now, for this particular ISA 65 by 65 by 6, the gross area is directly given in the steel table. So you have the steel table with you so that you can directly copy the value. Otherwise you have to calculate the gross area of the angle as we have done in the last video. What is it? L minus t by 2 into t plus b minus t by 2 into t. Isn't it? That is the area, the gross area of the angle. Or directly you will get it from the table, steel table, as 744 mm square. And also the value of CZ is given as 18.1 mm from the table. What is 18.1 mm? That is the distance from the center of gravity of the angle from the bottom. So the distance to the top will be equal to 65 minus 18.1. So this is directly given in the steel table. Understood? No need to calculate the center of gravity. So these are the two values you can directly copy from the steel table. Now the question is to find out what is LW, length of the weld, design the weld. We have already done one question from this part in the last video. അല്ലേ, നമ്മൾ നേരത്തെ ചെയ്ത ഒരു ക്വസ്റ്റ്യൻ, ഒന്നോ രണ്ടോ ക്വസ്റ്റ്യൻസ് നമ്മൾ ചെയ്തു. LW രണ്ട് പ്ലേറ്റ്സ് തമ്മിൽ ജോയിൻ ചെയ്യുമ്പോഴുള്ളത് നമ്മൾ കണ്ടു. ഇത് ഒരു ആംഗിൾ ആണെന്നുള്ള വ്യത്യാസമാണുള്ളത്. അപ്പോൾ എന്താണ് ഇവിടുത്തെ ഡിഫറൻസ് നോക്കാം. നമുക്കറിയാം സ്ട്രെങ്ത് ഓഫ് ദ മെമ്പർ കാണുന്ന ഫോർമുല എന്താണ്? വാട്ട് ഈസ് ദ സ്ട്രെങ്ത് ഓഫ് ദ മെമ്പർ? AG into FY divided by gamma MO. നമ്മൾ നേരത്തെ യൂസ് ചെയ്ത ഫോർമുല അല്ലേ? AG into FY divided by gamma MO equals 744 into Fy, the yield strength, stress 250 Newton per mm squared, the yield stress divided by gamma MO 1.1 from the IS code 800 2007. Isn't it? Now this is the strength of the plate. Now what is the strength of the weld? The strength of the weld is equal to LW into T, right? LW into T into FU divided by root 3 into the partial safety factor for the weld. It is 1.25 for shop welding. 1.25. ഇതൊക്കെ നമ്മുടെ നേരത്തെ യൂസ് ചെയ്ത ഫോർമുലയാണ്, ഒന്നും ഡിഫറൻസ് ഇല്ല. ഓക്കെ, LW into T into FU divided by root 3 into 1.25. So our question is to find out, to design a load to be transmitted equivalent to the full strength of the plate. So this can be equated to this one, 744 into 250 divided by 1.1. Okay, now here LW to be found out. What is T? T is the throat thickness. You know, T is equal to 0.7 into size of the weld. What is the size of the weld? Size of the weld is equal to the thickness of the plate, that is 6 mm minus 1.5 equals 4.5. So take it as 4 mm. 4 mm as the throat thickness T. Sorry, the size of the weld. Therefore, throat thickness T is equal to 0.7 into 4 equals 2.8 mm. So the throat thickness is equal to 2.8 mm. So that value you can equate here. LW into 2.8 into FU, what is it? 410. You know, it's the grade is Fe 410. So Fe will be equal to 410 Newton per mm squared divided by root 3 into 1.25 is equal to 744 into 250 divided by 1.1. So here the unknown is only LW, the length of the belt. Right? So by solving this, you will get LW is equal to 320 mm. Round ചെയ്യുമ്പോൾ നിങ്ങൾക്ക് 320 mm എന്ന് കിട്ടും by solving it. The total length of the weld is equal to 320. Now, from this, we have to calculate what is LW1, that means the length of the weld at bottom, and LW2, the length of the weld at top. So LW1 plus LW2 is equal to LW. Understood? Now, how can we do that? Here you know this 18.1 mm from the bottom, so that top will be equal to 65 minus 18.1 mm will be the distance from the top to the center of gravity. So by taking the moments, we can find out that value. That is, see here, 18.1 into LW1. See here, LW1 into 18.1 equals, what is it? LW2 into this distance equal to LW2 into 65 minus 18.1. അല്ലേ? അതായിരിക്കും ഈ distance. By equating this, we will get LW1 equals, what is it? LW1 equals LW2 into 65 minus 18.1, that will be equal to how much? 46.9 LW2, right? 46.9, this value divided by this 18.1. So LW1 equals LW2 into 46.1 by 18.1. So you will get LW1 in terms of LW2. LW1 in terms of LW2. So what is the total value? Now we can equate LW is equal to LW1 plus LW2. So here this we can equate instead of LW1 in terms of LW2, so that you can find out both LW1 and LW2 separately. So that is LW1 here and LW2. Understood? So this is the method of designing a weld for an angle. Right? In ISA 65 by 65 by 10, so that LW1 will be more than here LW2. So first calculate the total length of the weld. From that, find out what is LW1, what is LW2 by taking the moments. Right? LW1 into this distance, LW2 into this distance, LW1 into 18.1. This value 18.1 we'll get from the steel tables. So this is the method of solving this question on the design of weld of an ISA connected to a cassette plate. It's okay? Clear? Thank you.